Hello sir, this is Ridwan BHUGALOO. I am doing this video for the demo application. I have chosen the license plate recognition using OpenCV Python. So here is an example how the program works. So here is the original image. This is a grayscale image. This is a smoother image after applying a filter. This is a canny edge. This is the contours in the image. This is the top 30 contours. This is the final image where the license plate has been recognized, and this is a crop image of the license plate. As you can see, the characters in the license plate has successfully been recognized. And let's take another example. Take another image. So once again, this is the original image. This is a grayscale image. This is a smoother image. This is a canny edge. This is the contours in the image. This is the top 30 contours in the image. This is the final image where the license plate has been recognized, and this is the crop image of the license plate. Once again, the license plate, the characters in the license plate has been successfully recognized. So let's go and take a look at the Python code. So here are some libraries that have been imported. So first we read the image. This is the image. Then we have to resize the image to avoid any problem with higher resolution images. We display the original image. Then we have to convert the image to grayscale. This is done to reduce the dimension and complexity of the image. Also, the canny edge detection algorithm works only on grayscale images. This will also speed up other processes. We have also to reduce noise in the image. We have to apply a filter. The filter takes 4 parameters. The first parameter is the source image, that is here the grayscale image. The second parameter is the diameter of pixel. The third parameter is the sigma color, and the fourth parameter is the sigma space. It blurs unwanted details from the image to get a smoother image. Then once again we display the image. Then we have to perform the edge detection. The most easy and popular way is to use the canny edge method from OpenCV. It takes 3 parameters: the source image and the threshold 1 and threshold 2. This is the minimum and maximum threshold values. Only edges that have an intensity gradient more than the minimum threshold and maximum threshold will be displayed. So now we will start looking at contours in our image. The contour is a line joining all the contour points. So we will draw the contours on the image. The contour will be of the green color. Here is the code for the green color. We will display the image with all the contours in it. However, once the contours have been detected, we need to sort them from big to small. We will consider only the first 30 results. Then we will display the image with only the top 30 contours. So now we will use a for loop to filter the license plate among the obtained results. We will loop through all the results and check which has a rectangular shape, contour with 4 sides and a closed figure. The parameter is called the arc length, and we can find directly in Python using arc length function. The approx poly dp, we have used it because it approximates the curve of polygon with precision. Here 4 is used, it means that the rectangular shape and a closed figure. We will then crop the license plate, and we will save the image as license plate.png. So once again we will draw a rectangular shape of green color on the image around the license plate to make sure we have detected the license plate correctly. Then we will display the crop image of the license plate which we have saved previously here. Then we need to recognize a character in the image. So the character recognition uses the Pytesseract package, which is used to recognize character in images. Pytesseract will try to read the characters in the crop image and assign it to the variable text. Then we will print the license plate number is and display the text which is the characters from the license plate. However, sometimes there can be failed cases even though we have correctly recognized the license plate. There can be cases where the Tesseract library failed to recognize the characters properly. These issues can be solved by using a better orientation images or by configuring the Tesseract engine. Here is an example of a failed case. We'll take another image. So here is the original image, the grayscale image, the smoother version, the canny edge, the contours in the image, the top 30 contours, the final image. You can see we have correctly recognized the license plate. Here is the crop version. However, the Tesseract engine could not recognize the characters in the license plate. This can be solved by a better orientation image or by configuring the Tesseract engine. And that's it. Thank you for watching this video.